Hello everyone, welcome to our channel Learning at Home. Today we are going to learn some interesting concepts of decimals. This video will help you to understand how to compare two decimal numbers and will also help you to arrange a set of decimals according to its order. But before you start watching this video, kindly do subscribe to Learning at Home to learn about more such mathematical concepts. So, without further delay, let us begin. Before we learn how to compare two or more decimal numbers, let us first know about the three types of decimals. At first, we have like decimals. So, what are like decimals? Decimals having equal number of decimal places are called like decimals. Examples: 0.67, 1.23 and 25.68. Now, what are decimal places? The decimal places are represented by the number of digits present after a decimal point. Here, all the three examples have equal number of decimal places. That is, they have two digits after the decimal point. The next type of decimals are the unlike decimals. They are the opposite of like decimals. Decimals having different number of decimal places are called unlike decimals. Examples of unlike decimals are 0.67, 1.203 and 25.6. Here, all the three examples have different number of decimal places. The first example, 0.67, has two digits after the decimal point. The second example, 1.203, has three decimal places, and the third has one decimal place. Now, since we know the difference between like and unlike decimals, let us look at the question given on the screen and try to solve it. The question says, convert the following unlike decimals to like decimals. We have got three sets of unlike decimals and we have to convert them into like decimals. As we can see that both the first and the second numbers have one digit after the decimal point, but the third one has three digits after the decimal point. So now we have to add two more digits to both the first and the second number in order to make all of them into like decimals. We can do that by simply adding two zeros after 5 in case of the first number and 8 in case of the second number. Let us see how. So, in case of the first number, that is 0.5, we can make it into like decimal by adding two zeros after the digit 5. So 0.5 becomes 0.500. We need to know that the value of a decimal number will not change if zeros are added to the extreme right of the decimal part of the given decimal. We can also cancel these zeros without affecting the value of the decimal. Now let us look at the third unlike decimal, that is 3.8. We can change it to a like decimal by adding two zeros to it. So 3.8 becomes 3.800. The third unlike decimal, that is 1.586, already has three digits after the decimal point. So we need not do anything to it. So 0.500, 3.800 and 1.586 are the like decimals. The third type are the equivalent decimals. Decimal fractions which are converted into the same decimal numbers are called equivalent decimals. For example, 3 by 10, 30 by 100, and 300 by 1000 are equivalent decimal fractions, as these above fractions are converted into the same decimal number, which is 0.3. How are we getting the same decimal number? Let us see. The first decimal fraction, 3 by 10, when converted to a decimal number, will be 0.3. I have already explained this concept in the previous video. The link of the previous video is there in the description box. When we converted the second decimal fraction, 30 by 100, we get the decimal number as 0.30. Since we have just now learned that we can omit a 0 which is present at the extreme right of the decimal point, as it will not affect its value, so 0.30 can also be written as 0.3. Using the same logic, the third decimal fraction will also have its decimal number as 0.3. So we can see that all the decimal fractions are converted into the same decimal number, which is 0.3. Let us now use this concept to solve few sums. Let us read the question present on the screen. It says, write 2 or more decimal numbers equivalent to each of the given numbers. Here the first number given is 0.5. So we have to write 2 equivalent decimal numbers. So the first equivalent decimal number will be 0.50, because 0 at the extreme right of a decimal point can be easily omitted and its value will remain unaffected. So 0.50 can also be read as 0.5. Similarly, the second equivalent decimal number will be written as 0.500, as zeros at the extreme right of a decimal point can be cancelled. Therefore, 0.5, 0.50 and 0.500 are the equivalent decimals. Let us understand this concept with another example, which is 19.8. So the first equivalent decimal number will be 19.80. Since 0 at the extreme right of a decimal point can be easily omitted, so 19.80 can also be read as 19.8. The second equivalent decimal number can be 19.800, because 0 at the extreme right of a decimal point can be easily cancelled. Therefore, 19.8, 19.80 and 19.800 are the equivalent decimal numbers. Let us now understand another interesting concept of decimals, which is known as decimal places. I have already explained in the previous video that a decimal number is divided into two parts, a whole number part and a decimal part. So the number of decimal places is represented by the number of digits in the decimal part. Let us look at a few examples. The first example has number 3.2, where there is only one digit after the decimal point. So 3.2 has one decimal place. The second example has the decimal number 15.07, where there are two digits after the decimal point. So 15.07 has two decimal places. The third example is 0.239, which means there are three decimal places. Let us understand this concept clearly with the question written on the screen, which says how many decimal places are there in each of the following numbers. Let us look at the first number, which is 42.10. 42.10 have 2 digits on the right of the decimal point. Thus, it has 2 decimal places. Let us look at another example, which is 0.463. 0.463 have 3 digits on the right of the decimal point. Thus, it has 3 decimal places. Let us now understand what steps we need to follow while we are comparing two decimal numbers. Let us look at the first step, where we need to compare the whole number parts of the given decimal numbers. The decimal number which has a greater whole number part is obviously greater. What if the whole number parts are either equal or 0? Then we move on to the second step. If the whole number parts are equal or 0, then we compare the tens digit. The decimal number having greater digit at the tens place is greater. What will we do when the digit at the tens place is either equal or 0? Then we follow the third step, where if the tens place digits are equal or 0, then we will simply compare the hundredths digit. The decimal number having greater digit at the hundredths place is obviously greater. Now, using these 3 steps, let us solve another question, where the question says, choose the greater decimal number from each pair. Let us look at the first pair, where there are 2 numbers, 5.9 and 8.30. So here we will first look at the first step, where we will look at the whole numbers. The whole number part of the first number 5.9 is 5, and the whole number part of the second number, that is 8.30, is 8. So out of 5 and 8, 8 is greater. Therefore, 8.30 is the greater decimal number. Let us make this concept clear with another example, where we have 2 numbers, 0.831 and 0.509, where we can clearly see that the whole number part is 0. So now we will follow the second step. In the first number, 0.831, we have 8 tenths, 3 hundredths and 1 thousandths. The second number has 5 tenths and 9 thousandths. So we will now compare the digit at the tens place. The first number, 0.831, has 8 tenths, and the second number, 0.509, has 5 tenths. Since 8 tenths is greater, therefore 0.831 is the greater decimal number. Next, let us understand a very easy concept of decimals, which is ordering of the decimal number, which means we have to find out the ascending and descending order of a set of decimal numbers. Arranging a set of given numbers in ascending or descending order is very easy, as we have already understood how to compare two decimal numbers. We need to follow the 3 steps which we have already understood just a few minutes back. Let us first begin by understanding the concept of ascending order in case of decimals. Let us look at the first example, which has the decimal numbers 0.6, 4.87, 3.81 and 1.305. At first, we will look at the whole number parts, as we can clearly see that all the whole number parts are different. So finding out the ascending order of these set of given numbers is very easy. Ascending order means we will have to arrange from the smallest number to the greatest number. The whole number part of 0.6 is 0, 4.87 is 4, 3.81 is 3 and that of 1.305 is 1. Since we can clearly see that out of 0, 4, 3 and 1, the number having the smallest whole number part is 0. So we write that first. The next smallest whole number part is 1. So we write the number 1.305 next. Out of 4.87 and 3.81, 3.81 has the smallest whole number part. So we write that next. And lastly, the number which is left, that is 4.87, and which is the greatest among all the numbers, we write that next. So the ascending order of the given set of decimal numbers in example 1 is 0.6, 1.307, 3.81 and 4.87. Let us look at the second example, which is 0.8, 2.7, 1.63 and 0.34. As we can see that here 0.8 and 0.34 has both the whole numbers as 0. So we follow the second step, where if the whole number part of numbers is 0, then we move on to the digit of the tens place. So in case of 0.8, it has 8 in the tens place, and in case of 0.34, we have 3 in the tens place. Now out of 3 and 8, since 3 is the smallest number, so first we write the decimal number 0.34. The next smallest decimal number 0.8 is written. Now out of 2.7 and 1.63, the number having the smallest whole number part is 1.63. So we write that next, and lastly we write 2.7. So the ascending order of the given set of decimal numbers in example 2 is 0.34, 0.8, 1.63 and 2.7. Since we have understood the concept of ascending order in case of decimals, understanding descending order will be very easy. Let us look at the first example, which has got the decimal numbers 13.04, 0.59, 0.876 and 6.3. At first we will look at the whole number parts. Descending order means we will have to arrange from the greatest number to the smallest number. The whole number part of 13.04 is 13. That of 0.59 and 0.876 is 0. And lastly, the whole number part of 6.3 is 6. Since we can clearly see that out of the four whole number parts, 13 is the greatest. So our first number will be 13.04. Next out of the whole number parts 0 and 6. Since 6 is greatest, so we write the next number as 6.3. Next we have got two decimal numbers whose whole number parts are same. So we now move on to the tens place. Now in case of 0.59, 5 is in the tens place, and in case of 0.876, we have 8 in its tens place. Now since out of 5 and 8, 8 is the greatest, so we write the next number as 0.876, and lastly we write the smallest number out of all the four numbers, which is 0.59. So the descending order of the first example will be 13.04, 6.3, 0.876 and 0.59. Let us look at the second example, where we have got the decimal numbers 8.42, 0.439, 0.428 and 0.68. Now we can clearly see that the whole number parts of three decimal numbers are same, that is 0. So out of all the four decimal numbers, the number which has the greatest whole number part is 8. So we first write that the first number in the descending order will be 8.42. Next, Out of 0.439, 0.428 and 0.68, since 0.68 has 6 in its tens place, and out of 4 and 6, 6 is greater, so we write 0.68 next. Now, as we can clearly see, two numbers, that is 0.439 and 0.428, has both the whole number part and the tens place the same value, that is 0 and 4. So now, since the tens place and the whole number part is same, so we move on to the hundreds place. Now, in case of 0.439, 3 is in the hundreds place, and in case of 0.428, 2 is in the hundreds place. Now, out of 3 and 2, since 3 is the greatest, so we write the next greatest number as 0.439, and lastly, the smallest out of all the four numbers are 0.428. So the descending order of the second example is 8.42, 0.68, 0.439 and 0.428. So I end our today's video on comparing and ordering of decimals here. If you think you have understood the concept well, do give a thumbs up by clicking on the like button. Also, do not forget to subscribe to Learning at Home and press the bell icon so that you get notification whenever I post any such educational videos. So keep watching and stay safe.